Welcome to SynerJEE, JEE and NEET online classes.
The rate constant for the first order reaction is this much. What is the time required to reduce 2 grams of the reactant to 0.2 grams? Now here they are saying first order reaction. So first order reaction, what is the formula? K is equal to 2.303 divided by T into logarithm of A naught by A. A is the initial concentration, whereas this is the final concentration. Now, so rate constant is given. This value is given in the question only. 4.606 into 10 power minus 3. And they are asking what is the time. And initial concentration is also given as 2 grams. And final concentration is also given. Just you have to substitute. So T is equal to 2.303. I am bringing the K to the denominator and I am substituting that K, 4.606 into 10 power minus 3 into logarithm of A naught. A naught means initial concentration. Now concentration actually means moles per liter. Now moles per liter if you take, it can be written as mass divided by molecular weight divided by the moles by volume. I can write it as weight by molecular weight divided by volume. Now since both are in the same beaker, the substance is in the same beaker and volume of the solution is not changing with time. Therefore, if you take the ratio of A naught and A, the volume term will get cancelled and the same compound we are talking about. Therefore, it can be written as the ratio of mass of A naught, mass of A initially by mass of A finally. That means 2 grams divided by 0.2 grams. So 2 by 0.2 is 10 times. So log 10 by default is base is 10. So log 10 base 10 is 1. So this will be 2.303 divided by 4.606 into 10 power minus 3. It is around 2 times and this can be written as 1000 divided by 10 power minus 3. If it goes to the top, 1000. So 1000 divided by 2, which is 500. So 500 seconds is the answer for this. So this is the answer. The given element is being asked. See, whatever is given here, element, whatever value is given, this represents number of protons. This is atomic number. Atomic number means number of protons. And this is the mass number. Mass number represents number of protons plus number of neutrons. So indirectly they have given number of protons as 71 because Lu 71, 175 is given. So that means number of protons is 71. And we know that protons plus neutrons is the mass number, which is 175. So from this if you calculate number of neutrons also, number of neutrons we got as 104. So protons we know and neutrons we know. Since it is a neutral element, it is not a cation or anion, therefore number of protons must be equal to number of electrons. Then only there is no net charge in the element. Suppose if protons are more in number, it should exist in the form of cation. If electrons are more in number, it will exist in the form of anion. If both are equal, it is neutral. Since it is given as neutral one, therefore number of electrons also will be same as number of protons. So protons and electrons are 71. First they are asking protons. So protons should be 71. Next they are asking neutrons. And neutrons will be 104. And third they are asking electrons, and which is again 71. You have to see the sequence here. Because see 104, 71, 71 is there in the third option also, in the fourth option also. But are you really going in the sequence what they have mentioned? That is important. 71, 104, 71. So this is the right answer. Hydrolysis of sucrose is given by the reaction given sucrose plus water gives glucose and fructose. If the equilibrium constant is given as this and temperature is also given and delta G naught will be how much? There is a formula between delta G naught and equilibrium constant. Formula is minus RT ln equilibrium constant, and they are saying equilibrium constant is given as 2 into 10 power 13. So if you use that, minus R is 8.314 into temperature is 300 Kelvin into logarithm 2 into 10 power 13. So if you do this, then since you have taken R value in terms of 8.314, ultimately you will get answer also in terms of the joules. So here which option is matching with this 8.314 minus 8.314 into 300 into ln 2 into 10 power 13. So this answer is matching. So this is the right answer for this. The number of Faradays required to produce 20 grams of calcium from molten calcium chloride. See, we know the formula in the electrochemistry that mass divided by equivalent weight is equal to Q, charge which is passed through the solution in the electrolysis, divided by the 96,500 coulombs. Now this charge by 96,500 coulombs is the number of Faradays. Number of Faradays. Now, what is the mass which is produced in the electrolysis process? 20 grams. So 20 divided by equivalent weight is equal to number of Faradays. So if we calculate E, then we will get the answer which they are asking for. Now, equivalent weight is calculated as molecular weight or atomic weight divided by n factor. N factor means here number of electrons which are involved in the conversion process. Now since calcium is in molten calcium chloride, if you take, in calcium chloride, calcium is in +2 state, chlorine is in -1 state. So therefore, calcium +2, if it takes 2 electrons, it will convert into calcium. So therefore, electrons involved for production of calcium is 2 electrons from its ions. Therefore, n factor, number of electrons of calcium involved means is 2. So taking that as here, you will get calcium atomic mass is given in the question itself, 40 divided by 2, which is 20. So therefore, number of Faradays is calculated as is equal to mass divided by equivalent weight, 20 divided by 20 is equal to 1. Therefore, the answer which is matching with this is this. An electrolysis of dilute sulfuric acid using platinum electrodes, what will be obtained? See, dilute sulfuric acid contains H2SO4 and water. Now, when you electrolyze this one, at cathode, H plus will be reduced and becomes into H2. You can remember a shortcut like this: red cat anox. See, which says that reduction happens at the cathode and oxidation happens at the anode. So at cathode always reduction happens. Reduction means what? Acceptance of electrons is the reduction. So H plus is accepting electrons, so reduction. So and this reduction happens at the cathode. And anode, oxidation happens. Now at anode case, SO4 minus 2 is there, and SO4 minus 2 versus water. Among these two species, the oxidation potential of H2O will be more than the SO4 minus 2. That means oxidation potential of H2O is greater than oxidation potential of sulfate, which means H2O has more tendency to participate in oxidation at the anode electrode compared to the sulfate. Therefore, H2O will get oxidized even if you electrolyze Na2SO4 also at the anode. H2O is getting oxidized. So whenever sulfate is there in water, remember among sulfate and water has more potential to get oxidized. So H2O will be oxidized. Oxidation means losing of electrons. At anode, oxidation, that is losing of electrons, takes place. It will then forms O2, H plus and electrons. So if you balance it, this is the balanced equation. Anyway, so since in the oxidation process at anode, O2 gas is liberating. So they are asking here an electrolysis of dilute sulfuric acid, the product obtains at the anode. They are asking what happens at the anode, which gas is liberated at the anode. Since sulfate is not participating in oxidation, only water is participating, and it is producing a gas, O2 gas at anode. So option is matching with only second option. There are two gases are there, nitrogen and argon. One is 7 gram, other one is 8 grams. And total pressure is 27 bar. So they are asking what is the pressure of N2. Now here, if there is a container, contains N2 and argon, two gases are there. So total pressure will be pressure of N2 plus pressure of argon. So total pressure will be the individual summations. Now here, partial pressure of any gas is equal to mole fraction of the gas in the mixture multiplied by total pressure. This is the Dalton's law of partial pressures. So partial pressure of N2 is being asked. So this can be written as mole fraction of N2 multiplied by total pressure. This is already given. Total pressure is already given, this part. Now if you calculate this one, the first part, we will get to the answer. Now mole fraction means moles of the substance divided by the total moles. So let's calculate mole fraction first. So mole fraction of N2 is moles of N2 divided by total moles. Total moles means moles of N2 plus moles of argon. Moles of argon. Now, how to calculate moles of N2? Moles of N2 will be mass divided by the molecular weight. So mass of N2 divided by the molecular weight of N2. So if I substitute this, I'll get to the mole fraction. Here argon moles, how you will get? Mass of argon divided by the molecular weight of argon. So in the question it is given that 7 grams of N2 is there, 8 grams of argon is there. So 7 grams of N2. And what is the molecular weight of N2? Atomic mass of N2 is 14. since atomic mass of N is 14, since N2 has 2 atoms, so 14 into 2 will be the molecular weight, divided by, so 7 by 14 into 2 plus mass of argon is given as 8 in the problem. So 8 divided by atomic mass of argon is given as 40. So take it as 40. Now if you calculate this, 1 by 4 you are getting in the numerator, and divide by 1 by 4 plus 1 by 5. That means if you simplify this one, 5 divided by 9 you will get. Now 5 divided by 9 is the mole fraction. Now let's substitute in the other part, right side part. So partial pressure of N2 can be written as mole fraction of N2, which is 5 by 9, multiplied by total pressure. Total pressure is given in the problem itself as 27 bar. So let's substitute that, 27. So 3 times and 15. So 15 bar will be the final answer. So which is matching here? Only 15 bar. Fourth option is matching. Find out the solubility of NaOH twice, a 0.1 molarity NaOH. NaOH twice, if you write solid, and in water it dissociates into Na plus 2 aqueous plus 2 OH minus aqueous. Now suppose if let solubility be X. If it is X moles per liter solubility, then Na plus 2 will come out X, because if X is dissolved, then X moles per liter of Na plus 2 is coming, and double the number of OH minus. Double the number of OH minus means 2X moles per liter OH minus will come out if X is dissolved. If X moles per liter of solid dissolved, then X of nickel ions and 2X of hydroxide ions will come out. Now, but the total number of OH minus ions, there is a nickel NaOH is already present in the water. They are saying solubility of NaOH in 0.1 molarity. That means NaOH is already present in water of 0.1 molarity. And NaOH is a strong base, therefore it completely dissociates into Na plus and OH minus. So 0.1 molarity Na plus and 0.1 molarity OH minus already present in the water. So the total OH minus concentration, if you ask me, then it will be 0.1 plus 2X. 0.1 is already present and 2X came out from the solid nickel hydroxide. Now, according to the solubility product must be equal to Na plus 2 concentration into OH minus concentration square, because OH minus the stoichiometric coefficient is 2, therefore square. Now Na plus 2 concentration is X, and OH minus total concentration you have to take in the solution, whatever it is there, that you have to take, is equal in square is equal to KSP. And it is given that KSP values or solubility product is also given in the question as 2 into 10 power minus 15. This is solubility product. So solubility product is given as 2 into 10 power minus 15. So as you see here, since the value is very small, this is very small, I can say that even if you solve this equation, this will be a cubic equation in X terms. It is a cubic equation. So if you solve this equation by using mathematical rules, even then I can say that X value we will get is very small. If X value is very small, then only it will satisfy this product of x into 2x plus 0.1 square as 2 into 10 power minus 15. So since this is very small, x value is very small as compared to 0.1. So since x value is very small to compare as compared to 0.1, therefore I can approximate this as 2 into 10 power minus 15 is equal to x into 2x plus 0.1. I can write it as approximately 0.1. Why? Because if x value is very small compared to 0.1, x plus 0.1 can be approximated as 0.1. Because x is small, so I can neglect this x in the addition process. So, 2x plus 1 or x plus 0.1, anyway 2x can be neglected. So 0.1 I am writing in place of 2x plus 0.1 and square. Therefore, x will be 2 into 10 power minus 15 divided by 0.1, I can write 10 power minus 1 square. So that means 2 into 10 power minus 13. So that is the solubility, which they are asking to calculate solubility only. So in these cases, in the solubility problems, most of the times already some substance is present, and then the solubility, if you take the ions, for example, here already OH is present. Now the salt which is producing OH here is 2x, and the total OH is 0.1 plus 2x. In such cases you can neglect this x value as compared to 0.1 in the addition process. Why? Because in most of the cases you will see they will give the KSP values which is very, very small. Since KSP is very small, by solving such cubic or quadratic equations, ultimately we will get x value as very, very negligible value, 0.000 something value we will get. Since we will get very negligible value to satisfy the very small value on the LHS side, we can directly say instead of going into laborious calculations, we can directly tell, since x is negligible value, 2x plus 0.1, I can approximate it as the 0.1, and we can proceed the calculations further. It will simplify the results, it will simplify the calculations, and you will get the answer quickly. So 2 into 10 power minus 13 is the right answer. So this one is right. Solution of calcium chloride, magnesium chloride and NaCl. Now which will crystallize? Now in this question, there is already NaCl is there, and MgCl2 is there, and CaCl2 is there. Now when you pass HCl to it, which is getting crystallized, they are asking. Now what happens here? Calcium chloride, magnesium chloride, when they are present in water, calcium chloride and magnesium chloride, calcium and magnesium ions, they are very strongly bonded with the water molecules. Like this, in the octahedral fashion, the calcium ions and magnesium ions will be strongly bonded with the solvent water. So since they are strongly bonded or strongly solvated in the solvent water, this solvation or solution or dissolution of magnesium chloride or calcium chloride dissolution process this is called dissolution equation. Now this dissolution process is highly exothermic. Why it is highly exothermic? Because after breaking into ions, they are strongly surrounded by the solvent water molecules, and in that process high amount of energy will be released. Therefore it is highly exothermic process. Now since it is highly exothermic, and compared to NaCl, the Na plus does not form such octahedral things with the water. Therefore in case of NaCl, what happens? NaCl converting into Na plus and Cl minus, actually this is delta H is not exothermic, in fact this is endothermic. Why we are discussing all these things? See, delta G of dissolution process, I can write it as delta H of dissolution process minus T into delta S according to the thermodynamics. Now here, delta S means increase in the entropy, or increase in the disorder. So now see here, when ionic solids, when you take and when they are dissolved in water, it is dividing into the different particles. That means if it is splitting into more particles, then more disorder or more random movements come into picture. Therefore, delta S of dissolution process is always positive. Yes, delta S of dissolution is always positive quantity, because the dissolution of the ionic compounds, particles are splitting into more number of particles. Therefore, disorder and entropy will increase. So this total value will be therefore negative quantity. Minus T into delta S, if you do, it is a negative quantity. Now this delta H, in the case of for NgCl2 or calcium chloride, we know that delta H is negative. So delta H is negative quantity and minus T into positive quantity, this total value will be negative quantity. So they are highly dissolved. This delta H value is high negative quantity, you will get high value. So they are highly dissolved. Whereas for NaCl, if we take, delta S is positive, but delta H is also positive. So here what will happen, this positive quantity and minus T into positive quantity, if you do, definitely here actually entropy delta S value is more. So overall it is negative only, but it has less value, because delta H is a positive quantity, it has less value. Since delta G is negative, this salt also will get dissolved in the water, like calcium chloride, magnesium chloride. Whenever delta G of a process is negative, the process is feasible, it will happen on its own. So so therefore NaCl also soluble in water, magnesium and calcium chlorides also soluble in water. But the thing is, magnesium and calcium chlorides value is more highly negative, means it is highly soluble, whereas these are highly soluble, whereas this one is less soluble relatively. Since NaCl is less soluble and magnesium and calcium chlorides are highly soluble, now when you add HCl, what will happen? So compared to calcium and magnesium chloride, NaCl is less soluble. Therefore, if you add HCl, this HCl common ion effect, H plus and Cl minus, it will divide, and this Cl minus will push the reaction in the backward direction according to the Le-Chatelier's principle. If common ion is there already present, and then it will push the reaction in the backward direction. Therefore, NaCl solubility, whatever NaCl is dissolved, that will come out as a solid form, because Cl minus from HCl is pushing the reaction in the backward direction. And among NaCl, NgCl2 and calcium chloride, calcium and magnesium chlorides are more soluble, therefore they do not experience much of this effect. NaCl being less soluble compound relatively, it is getting this impact due to common ion effect. Therefore, as a result, NaCl will precipitate as a solid. So here which option therefore is matching? NaCl will be precipitating. This is the right option for this one. The mixture which shows positive deviation from Raoult's law. See, what mixtures will show positive deviation? There are three kinds of solutions. One is ideal solution, one is non-ideal with positive deviation, and non-ideal with negative deviation. So what is positive deviation and what is negative deviation? Suppose if A liquid is there and it is mixed with B liquid to form a mixture AB. If AA intermolecular interactions and BB intermolecular interactions and AB intermolecular interactions, if these both three are equal, approximately equal, then such solution is called non-ideal solution. Such solution is called ideal solution. Suppose if AA interactions or BB interactions are stronger than AB interactions, then what happens? Many A and B molecules will escape from the mixture. Therefore, here the real pressure will be more than expected pressure. It is called positive deviated solution. And suppose if AA interactions and BB interactions are weaker than AB interactions, then since AB interactions are strong, so molecules will remain in the liquid state more in number. Therefore, pressure real will be less than the pressure expected. Pressure expected means Raoult's pressure. So compared to that, pressure real will be less. So since pressure real is less, we call it negative deviated solution. So like this, a positive deviated solution, a negative deviated solution, and ideal solution. There are three kinds of solutions exist here. Now here in NCERT there are certain examples given for positive deviation, negative deviation, and ideal solution. In case of benzene and toluene intermolecular forces are approximately same, so it comes under the ideal solution. Acetone and chloroform. Acetone and chloroform, the acetone structure and chloroform. The hydrogen and chlorine, there is an intermolecular hydrogen bonding is there, because of which the AB interactions are stronger here. So AB interactions here are stronger than the normal individual interactions. Therefore, it comes under the negative deviation. This is an example of negative deviation from Raoult's law. And chloroethane and bromoethane. Now this is an example of ideal solution. Almost intermolecular forces are almost same. It is an example of ideal solution. All these are there in your NCERT textbook. Ethanol and acetone. Ethanol and acetone comes under the example of positive deviation. Because originally intermolecular forces, alcohol and alcohol, there is a good hydrogen bonding will be there between alcohols, where not only oxygen, hydrogen also participate in the hydrogen bonding. Whereas when alcohol is surrounded by the acetone molecules, now when alcohol is surrounded by the acetone molecules, for example if I take acetone, now here hydrogen and oxygen of acetone, hydrogen of alcohol or oxygen of acetone, there will be hydrogen bonding between them. But for oxygen, there is no hydrogen present in the acetone to participate in the hydrogen bonding. Although there are hydrogens present in acetone, they are insufficient to participate in hydrogen bonding because they should be connected to the good electronegative atoms. So therefore, this oxygen is not participating in the hydrogen bonding. That's why in the mixture, when you mix alcohol and acetone, the intermolecular hydrogen bondings are less in number as compared to the pure alcohol case. So in other words, AB interactions are weaker as compared to the AA or BB interactions. So therefore, it comes under the positive deviated solution. Now they are asking which one is the positive deviated. So therefore, only one answer is matching with it. That is, fourth option is matching here. The freezing point depression constant Kf is given is this much, and they are asking what is the freezing point depression of molality this much. Non-electrolyte electrolyte solute. See, there is a formula minus delta Tf. Delta means final minus initial. So final freezing point minus initial freezing point minus sign wheel means initial freezing point minus final freezing point. Initial minus final. Because delta means final minus initial. If you put minus sign, it will become initial minus final. This can be written as I into Kf into molality. I is the Van 't Hoff factor. Suppose if NaCl is there, Van 't Hoff factor is 2 because it divides into 2 particles. And if suppose MgCl2 is there, it divides into 3 particles, 1 magnesium and 2 chlorines. So I Van 't Hoff factor becomes 3. Now here they are saying non-electrolyte. Non-electrolyte, why they are saying? That means it is not dividing into ions in water. If NaCl, if you take, it is dividing into ions, Na plus Cl minus. MgCl2 if you take, it is also dividing into ions, Mg plus 2 and 2Cl minus. But if you take glucose, glucose is not dividing into anything. So this is called non-electrolyte. So if something is not dividing into ions in water, then for such substance, Van 't Hoff factor is 1. If it is dividing, suppose for example NaCl, it is dividing into 2, its Van 't Hoff factor will be 2 and MgCl2 Van 't Hoff factor will be 3. Now therefore, indirectly they are saying take Van 't Hoff factor as 1 and Kf is given as 5.12 and molality. Molality is also given 0.078. So if you multiply these 3 quantities, around 0.4 Kelvin. So only one option is matching with it, that is 4th. Which of the following has maximum number of atoms? How to calculate the number of atoms? Number of atoms can be calculated in a species as mass of the species divided by the molecular weight or atomic weight multiplied by atomicity into Avogadro number. See what we are doing. Suppose if it is a molecule, then this will give you the moles. This is the moles of molecules. Now this moles, when we divide with atomicity, atomicity means number of atoms present in the molecule or number of atoms present in the representation. For example, if you take O2, O2 has atomicity 2, N2 again 2. If S8 is there, atomicity is 8, P4 atomicity is 4, in that manner. So now, number of atoms present we are multiplying. So indirectly we are converting moles of molecules into moles of atoms. Once we know moles of atoms, 1 mole contains Avogadro number. If you multiply with the Avogadro number, we will get the total number of atoms. So if you do that for each and every element here, each and every option, first option is magnesium. Now for magnesium, mass is 1 gram divided by atomic mass is also given itself, here itself, 1 by 24 into atomicity. Look at the atomicity here. It is not written as Mg2 or Mg3 like that. So atomicity is 1 because it is a metallic compound. For metallic compounds like magnesium, sodium, iron, etc. in these cases, we represent it as Mg, sodium, iron. In this manner we represent. We don't write any Mg2 or Mg10 like that. We don't write because they are metallic in nature. In metals, all the atoms are present in a solid. They are very close like this. All atoms are present, and we should not write them as a some with Mg2 or Mg3 kind of notation. So this is the representation of this one. Now, so since metals are represented in the atomicity 1 form, so if you multiply with 1 and Avogadro number, I will get the total number of atoms here. Now if you look at the O2 case, oxygen is not a metal, that's why it is written clearly as O2 Okay, and mass is given as again 1 gram. So 1 gram divided by, see here, what is the molecular weight? This is a molecule, and each oxygen's atomic mass is given as 16. Since it is a molecule, since 2 oxygens are present, total molecular weight you have to write. Whatever molecule you have taken, total molecular weight you have to write at the denominator, then only you will get the moles of molecules. Now we got moles of molecules multiplied by atomicity. Atomicity is take 2 here because O2 is there, multiplied by Avogadro number. There is no need to multiply with substitute Avogadro number and multiply, because here we have to compare and we have to decide which one has maximum number of atoms. Avogadro number is anyway commonly coming in all, so we need not multiply and calculate this thing. And lithium, similarly lithium is also a metal, therefore atomicity, in the atomicity we take it as 1 and represent the element, and that's why there is no Li2 or Li3 here. Is the metallic compound. Now 1 gram divided by, and 7 is the atomic mass multiplied by atomicity 1 into Avogadro number. So like this, if you write, again silver is also a metal, so again therefore 1 gram divided by atomic mass, which is 108, and atomicity is 1 into Avogadro number. So if you look at all these things, numerator is 1 here, first case, so it is 1 by Na by 24, I can write this one. And here if you cancel 2, you can write it as Na by 16. And here if you you can write it as Na by 7. And here Na by 108. Now they are asking which one has a maximum value. So the one which has a denominator smaller value is there, it will have a overall maximum value, because numerator is same in all of them. So if denominator is small, that overall value will be higher value. So which one is denominator small among all? This one has denominator small, therefore this will have a higher value, lithium. So answer should be 3 answer therefore. In this question, measuring the zeta potential is useful in determining which property of the colloidal solution. Zeta potential is the potential between fixed layer and the movable layer around the colloidal particle. Now there is a, suppose if particle is there, there will be one layer forms around it due to adsorption process. One layer will form and come and attach to it. It is called fixed layer. One layer is called fixed layer. Suppose if it is positive layer, one more layer come and attach surrounding this one of opposite charge species in the solution will come and adsorb on this. This is called movable layer or diffuse layer. Now this is not very fixed layer, this is movable, the other one is the fixed layer. Now this zeta potential will help us to identify whether the colloidal particle is highly stable or less stable. If zeta potential is strong, then see this plus and minus layers are very strongly present in around the particle, so it is not easy to break them. If zeta potential is weak, then what happens? It is easy to remove that negative layer first, then followed by the positive layer, then easily the molecules will form the precipitate. So zeta potential and the stability are the directly proportional. Higher the zeta potential, higher the stability. So therefore, The one which is matching with the given thing is, which property is connected to it? Stability of the colloidal particles. This is what the answer for this question. An element has a body-centered cubic structure with a cell edge of 288 picometers. What is the atomic radius asking? They are asking. Now, in body-centered cubic, there is a one atom at the body center, and also there are atoms at the corners. No, actually, the corner atoms, all four here above 4 atoms, 1, 2, 3, 4. Similarly, the below 4 atoms, 5, 6, 7, 8. The central atom, whatever is there, middle of the cube, the central atom, this is in contact with the above 4 atoms and below 4 atoms. So with above 4, it is in contact, and similarly below 4 also it is in contact. So it is in the center and it is touching all 8 atoms. So if you take the body diagonal, so body diagonal of a cube, if you take, suppose if this is back side of the top face, top back, let's say TB, and this is bottom face and front, so let's call it BF. So this is bottom front point, this is top side back point. Now if you join these 2 points, this is called body diagonal. Now in this diagonal, if I ask you what is the length of this diagonal in a cube, it will be root 3 times of A. And this root 3A must be equal to what here, here one sphere is existing, one atom is existing, here one atom is existing, and in the center one atom is existing actually at the body center, at the center of the cube. And the center of the cube is touching this one as well as the below cube also. Both are in contact with the center one. Therefore, the total the length can be written as 2r is the diameter of the central atom, and r is the radius of the upper atom, and r is the radius of the down atom. So the total length, the spheres when they are in contact like this is the BF point, and this is the TB point, and this is the central atom. So if you join these two, this is what length we are talking about, which is root 3 times of the A, where A is the edge length of the cube. Now this can be written as, now this is 2r and this is radius r, this is radius r, so that is 4r. So 4r is equal to root 3a. And they are asking what is the atomic radius. So atomic radius can be written as root 3 times of A by 4. And A is given as 288 in the question itself. So root 3 times of 288 divided by 4. So if you see which option is correctly matching, root 3 times of 288 by 4 is this. What is the change in oxidation number of the following? Of carbon only they are expecting. So on here carbon is in CH4 and here carbon is in CCl4. In CH4, if you take hydrogen oxidation state in general is +1 in its compounds. So let's take oxygen as X. Therefore X plus 4 into plus 1 is equal to charge of the molecule, which is 0. So by taking oxidation state of carbon as X and H as +1, you will get oxidation state of carbon as -4. Whereas in CCl4, if you take and taking carbon as Y, which you have to find out, and chlorine in its compounds general oxidation state is -1. So if you take that, Y plus 4 into -1 is equal total charge of the species, which is a neutral molecule. So it is 0. It is not a cation or anion, so it is neutral. So 0. So if you equate, you will get Y is equal to +4. So oxidation state of carbon is changing from -4 to +4. So the answer matching with this is second option. Here they are asking for free expansion of ideal gas under adiabatic condition. Now in free expansion, what happens? Suppose if I take a beaker and a vessel, and one side there is a vacuum is there, and other side gas is there. Now if you open the slit here, then gas will rush out into the vacuum. It occupies the space there in the vacuum. So when it is occupying, it is expanding. Gas is expanding in that process. And is there any external pressure here? There is no external pressure available here. P external, because gas is going into the vacuum, and on the other side there is no gas or there is no substance, there is nothing is present to oppose this gas. Therefore external means the pressure which is applied on the gas is 0. Since external is 0, it is called free expansion. This is called free expansion process, because nothing is opposing or restricting the expansion of the gas. Now in this free expansion, they are saying it is adiabatic. Adiabatic means there is no heat supply or heat is not given and heat is not taken. There is no exchange of heat energy between gas and the other surroundings. Therefore Q is equal to 0. Sorry, Q is equal to 0 is the adiabatic case. Now if Q is equal to 0, and since external pressure is 0, we can say that work done can be said as minus integral of minus P external into delta V. Since P external is 0, this total value is 0. Since P external is 0 for this case. Now, so Q is already 0 because adiabatic condition, and work done is also 0 here. And according to first law of thermodynamics, we know that first law says that change in internal energy is equal to heat plus work done, and work done is 0, heat is 0. Therefore, we will get delta U also must be 0. Now delta U is a function of temperature. Delta U is a function of temperature. That means if temperature is changed, delta U will be changed. For ideal gases, delta U is only dependent on temperature, nothing else. Since delta U is 0, we can say that means there is no change in temperature for this system. Because if change in temperature happens, then definitely, since delta U is only dependent on temperature, if temperature changes are there, delta U definitely change will be there. But here delta U there is no change. That means delta T, or there is no change in temperature, since delta U is 0. So there is no change in temperature, there is no change in internal energy, and work done is 0, and Q is equal to also 0. Now let's see which is correct option for this. Now here first option Q is greater than 0 they have given. So this is wrong. Q is equal to 0. First adiabatic they have given, so Q must be 0. So here Q is equal to 0, here Q is equal to 0. Again here it is not. So among 2 and 3, 1 is the right option. And delta T is 0. Yes, there is no change in temperature also, but here delta T is given as less than 0. It is wrong. And here work done is equal to 0. This is yes, there is no external pressure available, so work done will be 0. And here work done is given as non-zero. Therefore only one option is matching with all things, that is second. For the reaction, the correct option is. Now how to solve these problems? It is given as 2Cl gas giving Cl2. Now when here what is happening, there is a chlorine is there, and between two chlorines a bond is forming. Cl and Cl, a bond is forming, and when bond is formed, energy will be released. When bond is formed, energy is released. Since energy is released, it is an exothermic process. That means delta H is less than 0, exothermic. So now we can say its delta H is less than 0, exothermic. Now what about change in entropy? Entropy is a measure of disorder. That means it measures how disorderly the system is. If more disorder is there, more entropy will be there. And if less disorder is there, less entropy will be there. Now, in case of this reaction, there are two atoms are becoming into one molecule. If more number of gaseous molecules are there, then more disorder will be there. Disorder and number of gas molecules are directly proportional. If more gas molecules are there, more disorder will be there. Why more disorder? Because gas molecules are gaseous particles, whether it is a molecules or atoms. If they are randomly moving, they are actually randomly moving. So when they are randomly moving, disorder will be more. If more gas particles are there in a system or in a beaker, then more random movements will be there. That means more disorder will be there. So that's why number of gas molecules, and if more number of gas molecules are there, more random movements will be there. More randomness is there, more disorder will be there. Therefore, here if you see, here less number of gas molecules are there. Less number of gas particles are there on the LHS side. Sorry, more number of gas particles are there on the LHS side. Because two moles are there converting into 1 mole. So more number of gas particles are there on the LHS side. What about RHS side? RHS side, less number of gas particles are there. How I am saying less number of gas particles? Here 2 moles you have started with, and it is converting into 1 mole. So 2 moles of gaseous atoms or gaseous particles if you take initially, then it is finally converting into only 1 mole. Half of it is connected to the other half. Then therefore ultimately 1 mole of gas particles are resulting. So less number of gas particles are there finally. Initially more number of gas particles are there. Therefore initially disorder is there because more random movements will be there. Initially more disorder and finally less disorder. That means here entropy will be, first case, if entropy is S1, if you say S1 will be more. And second case, if entropy, if you call it this RHS entropy is S2, S2 is less because less number of gas particles. So entropy value or disorder value will be less. So delta S, they are asking for the delta S. Delta S means what? Finally whatever entropy is there after the reaction and minus before the reaction entropy. Since S2 value is less and S1 value we have written as more, so therefore S2 minus S1 will be negative quantity. So delta S is negative and delta H in the beginning only we have discussed it is positive. So see which one is matching with it. Delta H is negative and delta S is also negative. So delta H is negative we got and delta S is also negative we got. So let's select this option. So this is the right option for this.
Dear students, if you really understood the concept and if you think you really benefited from this video, then please subscribe, like and share this video. Dear students, if you want to take full benefit of these classes, join our interactive live online classes by calling the phone number displayed on the screen. Thank you.